This week, we will also be talking about how light behaves. Light waves behave in four particularly interesting and useful ways that we describe as reflection, refraction, diffraction, and absorption. As you listen and watch this presentation, we would like you to think about two things. How does light travel, and how can light change direction? The amount of light an object reflects depends on the object's surface. A smooth surface like that of a mirror reflects nearly all of the light that strikes it. A rough surface like that of soil reflects much less of the light that strikes it. The rest of the light is absorbed. You have seen that visible light is part of the electromagnetic spectrum. The light appears white, however, light is a mixture of different wavelengths of light. Each of these wavelengths is seen by the human eye as different colors. When white light passes through a prism, its path changes and the white light is separated into colors of the visible spectrum. These colors are red, orange, yellow, green, blue, and violet. The color of an object depends on the wavelengths of light. A cucumber looks green because it reflects green light and absorbs the other wavelengths. A carrot looks orange because it reflects the orange light and absorbs all the other wavelengths. A white object, such as a blank sheet of paper, reflects all wavelengths of light, and a black object absorbs all wavelengths of light and reflects very little light. Have you ever crossed a parking lot on a hot sunny day and felt the heat from the asphalt? The asphalt has become very hot because its black color absorbs so much light and thermal energy from the sun. A strong beam of light shines from a lighthouse. If you look at the beam of light, you can see that it doesn't curve or bend. Light travels in a straight line. A beam of light doesn't change directions unless it actually strikes something. When light strikes an object, some of the light will bounce off the surface of that object. The bouncing of light on the surface is called reflection. Well, you must know that the sun produces light. The moon, however, does not produce light. You can see the moon because it reflects sunlight. Astronauts on the moon were able to see Earth because Earth reflects sunlight too. A smooth surface such as a mirror reflects light well. When you stand in front of a mirror, you see yourself in the mirror. Your image appears to be as far behind the mirror as you are in front of it. A lighthouse warns ship captains about the dangerous rocks and other obstacles. A mirror bends that light source in a lighthouse and reflects the light out in one direction. The light source rotates so the beam can light up a large area. Now, light waves travel in straight lines through empty spaces. We know it's called a vacuum. But more interesting things happen to them when they travel through other materials, especially when they move from one material to another. That's not unusual because we do the same thing ourselves. Have you ever noticed how your body slows down when you try to walk into the water? You go racing down the beach at Canal Park at top speed, but as soon as you hit Lake Superior, you slow right down. No matter how hard you try, you cannot run as quickly through the water as you were through the air. The dense liquid is harder to push out of the way, so it slows down. Exactly the same thing happens to light if you shine it into water or glass or plastic or another more dense material. It slows down quite dramatically. This tends to make the light wave bend, something we call refraction. You can see refraction in the pencil in the water. Now, diffraction is the slight bending of light as it passes around the edge of an object. The amount of bending depends on the relative size of the wavelength of the light to the size of the opening. If the opening is much larger than the light's wavelength, the bending will almost be unnoticeable. However, if they're too closer in size or equal, the amount of bending is considerable and easily seen with the human eye. If you scrunch up your eyes and look at a street light in the dark, and then you close your eyes, the light seems to spread out in strange stripes as it squeezes through the narrow gaps between your eyelids and eyelashes. Well, the tighter you close your eyes, the more the light spreads out. This is called diffraction, and you can see this in the picture. Light waves. Let's assume they are indeed waves for now. They behave in four particularly interesting and useful ways that we describe as reflection, refraction, diffraction, and absorption. And let's face it, without it, where would we be? We would be in the dark.